All right, welcome back to Algebra 2 reviewing for the first semester final. We're going to be solving systems algebraically and graphically. So first up for algebraically, I put one of the tougher problems on here which has 3 equations. So we're going to label our 3 equations as A, B, and C. And we want to try to eliminate our x's from them first. So here I could take -2 times my A equation, which would give me a -2x minus a 4y minus a 2z is equal to -20. And then I could just add on to it my B equation, which is 2x minus y plus 3z is equal to -5. Doing so, my x's now cancel, and we're left with -5y plus z is equal to -25. This then creates a new equation which we will call D. Now I used my A equation, my B equation. I must now use my C equation. So C is 2x minus 3y minus 5z is equal to 27. I could just combine this with -2a, or I could combine it with a -b. I'll combine this one with -2 times my a, since I already figured out what it was up there. So -2x minus 4y minus 2z is equal to -20. Here the x's now cancel. We have a -7y minus a 7z is equal to 7. We'll call this equation E. E, we can simplify. 7, 7, and 7. Why don't we just divide everything by 7 to make it a little bit simpler to work with? So now equation E is -y minus z is equal to 1. So now I'm going to combine my 2 variable equations, my D and E, and try to get rid of either my y's or my z's. Notice here I have a plus z and a minus z. So I can already get rid of them by just adding them together. So that's exactly what we'll do. So we'll add these together. We'll be left with -6y. The z's now cancel. This is equal to -24. Divide by -6, and y is equal to a +4. One of our solutions. Now that we have this, we take this y value and we either go back to D or to E and plug it in. I'm going to plug it in right here to E. So -4 minus z equals 1. I have to add the 4 over. -z is equal to 5. Therefore, positive z should be equal to -5. Second solution. Now we need to find x. So to find x, I'm going to take the A equation, plug in my y's and my z's that I know, and find x. So x plus 2 times my y is 4, plus my z is -5 is equal to 10. Well, 2 times 4, that is 8. 8 plus -5 is 3. So x plus 3 equals 10. Subtract my 3 over, so x is equal to 7. So my 3 solutions are x is 7, y is 4, and z is -5. Recall that this is an ordered triplet. We put it in alphabetical order. So 7, 4, -5, because that is representing one point where these 3 planes intersect. Next up, we're going to solve graphically. So here we want to solve this system graphically. So we have to graph the lines, so we want the y alone. So in this case, we'd have to subtract the 3x over. So we get y equals -3x plus 6. We will graph that. Here we go up to plus 6, go a slope of -3. So down 3 over 1, down 3 over 1, down 3 over 1. Get a nice ruler and draw that beautiful straight line in. Next line says y equals 3. So I go up to y equals 3. There is no x. So that means this is just a horizontal line at 3. I look and identify where my intersection point is, which is right here. And I just need to state that intersection point. That intersection point is at 1, 3. So 1, 3 is my solution. Next one, we are also going to solve graphically. The only difference here is that they have inequality signs. So since there's inequality signs, that means we will be shading. One nice thing about these is that y is already alone. So for the first equation, our y-intercept is 4. And then we have a slope of -2. So down 2 over 1, down 2 over 1, down 2 over 1. We are only greater than, so we will dash that line in. Second equation, y is less than or equal to x minus 2, so our y-intercept is -2. Slope of 1, so up 1 over 1. This is less than or equal to, so this is going to be a solid line. And now we need to see where these two regions intersect. So this first one says y is greater than. So y, here's where we cross the y-axis for our first line, is greater than is above it. Okay, so that's everything over on this side of that dashed line. Second one, it says less than or equal to. So here's our second line, here's where we cross the y, here's our less than. So that's everything over on this side of the line. We want to look at where the two lines intersect. We see that our yellows and our greens intersect right over here. So this would ultimately be our shaded region. So that is solving graphically.